Please give me a quick second and this laser pointer. Good afternoon, class. We are looking at section 3.1, derivatives and rates of change. Part 2, we're going to finish it up. We've already done a bunch of examples. We want to find the derivative, aka also known as instantaneous rate of change of f of x. The function f of x is x squared minus 8x plus 9 at a specific point x equals 5. And so we're going to use one of those definitions. More specifically, this is more common. So f prime of a, in this case, f prime of 5, is the limit of f of a plus h. That means the limit of f of 5 plus h minus f of a minus f of 5 over h. That's what we need to do. Now, a couple of things I want to mention. Number one, you can simplify this numerator and at the end apply the limit. But when you want to apply the limit at the end, here's the second point that's very important. You can't replace the h with 0 unless you have the lim sign. Lim as h approaches 0 and then go to that. So sometimes students or people in general simplify this expression. But in any event, I like to keep the lim sign from a to z. And so what is f of 5 plus h? So we go to this formula, 5 plus h squared minus 8 times 5 plus h plus 9. And what is f of 5? 5 squared minus 8 times 5 plus 9. So I hope you see that. In essence, all you have to do is simplify the numerator. 5 plus h squared, a plus b and a minus b quantity squared. A plus b squared is a squared plus 2ab plus b squared. So this is 5 squared or 25 plus 2 times 5 times h, 10h plus h squared. This one we distribute, we get minus 40. This one minus 8h, and this is plus 9. Now, this is 25. This is minus 40. This is plus 9. Let's say minus 25 plus 40 and minus 9. The reason I didn't simplify the, what's inside the parentheses is because this one cancels out this. Negative 40 cancels out positive 40. 9, negative 9. So it makes it very nice and easy. So the numerator is left with 10h minus 8h, which is 2h plus h squared. Now we can factor the h from the numerator. Remember, it is the 0 in the denominator, which is bad, and that's why we are hoping to get rid of it, and we do. And the limit of 2 plus h as h approaches 0. And I want to explain this. This is extremely important. If you don't have the limit sign, you can't say 2 plus h is 2. The limit sign says replace the h with 0 and you get 2. That's how you arrive at the answer, and I can't emphasize this enough. So a quick recap. Use one of those formula, the limit of f of a plus h minus f of a over h as h approaches 0, and we apply it to number 5. We come up with the answer. All right. The distance in feet of an object from a starting point is given by the function s of t equals 2t squared minus 5t plus 4, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? First, basic elementary algebra. The concept of average velocity, total distance over total time. Okay? You cover 100 miles over the course of 2 hours, you do 50 miles per hour. That's the meaning of it on the average. So from 2 to 4, when 2 points in time is given, that means the average. And so s of t sub 2 minus s of t sub 1 over t sub 2 minus t sub 1. And of course, that means s of 4 minus s of 2 over 4 minus 2. Of course, the denominator is 2. The numerator, s of 4. 2 times 4 squared minus 5 times 4 plus 40. Minus s of 2. 2 times 2 squared minus 5 times 2 plus 40. So all you have to do is simplify the numerator. The denominator is obviously 4 minus 2 or 2. 4 squared, 16. Times 232 minus 20 plus 40, and that gives us 52. 2 squared is 4, times 2 is 8 minus 10 plus 40. So it's minus 38. 52 minus 38 is 14 over 2, 7 feet per second. Units of the numerator over units of time. Units of the distance over units of time. Feet per second. What is the instantaneous velocity of the object at 4 seconds? Again, I want to make sure everybody understands that in this case, we have 2 points in time, in this case only one, and that means instantaneous. So even if they don't mention average, this means average, and this means instantaneous because it's 1 point in time. So we are going to use the differentiation formula. So V of instantaneous is the limit as h approaches 0 of s of a plus h minus s of a over h, and a is 4. So we want V of 4, if you will. So S of 4 plus H, that means 2 times 4 plus H, quantity squared, minus 5 times 4 plus H, plus 4. S of 4, it's been calculated already, so minus 52. We don't have to redo it again. This one, again, A plus B quantity squared is A squared, 16, plus 2 times 4 times H, 8H, plus H squared. We're going to distribute the 2. We get 32 plus 16H plus 2H squared. We're going to distribute the negative 5. We get minus 20 minus 5H plus 40 minus 52. Now, if you look at the numbers, 32 and 40, they add up to 72. Negative 20 and negative 52, they add up to negative 72. They add up to 0. So in the numerator, we have the 2h squared, and we combine these two into 11h. We factor out the h from the numerator. We can drop the common factor of h. And now if you replace it, you get 11. Again, units of the numerator over units of the denominator, 11 feet per second. That's the final answer. So, when you're given 2 points in time, you're interested in average velocity. When you're given 1 point in time, you're interested in instantaneous velocity. All right, we want to find an equation of a tangent line for this function at this pair. So we are going to go with the fact that a is 16, the function is square root of x, and we're going to use one of the formulas for the slope. M is the limit of f of a plus h minus f of a over h as h approaches to 0. So M, that means f prime of 16, and replace the a with 16. So that means the limit as h approaches 0, f of 16 plus h, that means square root of 16 plus h, minus f of 16. You can use 4 or square root of 16, it doesn't matter. And I hope you see that if you plug in 0, this becomes 16, this is 16, there, you know, square root of 16 minus square root of 16 is 0. So you have 0 over 0, which means you have to use your algebraic technique. And of course, because the square root is involved, you are going to go with the conjugate of a minus b, a plus b. The conjugate of the numerator, you write the same thing with the plus sign. So you multiply and divide by it. Again, as far as the denominator is concerned, you keep it as a product. Remember, h is approaching 0. This is the problem. This 0, the 0 in the denominator is a problem. So you keep it as a product. And the numerator, you get a squared, which is square root of 16 plus h quantity squared minus square root of 16, or simply 4 quantity squared. You get 16 plus h minus 16 in the numerator. The denominator, you just don't touch it. And these two cancel each other. The numerator is h. And we have what we wanted. Remember, going back here, the problem is the 0 in the denominator, and now you can cancel it. So h goes away. So the numerator becomes 1. Now, if you apply the 0, this is square root of 16, this is square root of 16, 4 and 4, they add up to 8. And now you're ready to find the equation of a tangent line. Y minus y1, that means y minus 4 equals m 1 over 8, x minus x of 1, that means 16. And we're going to distribute, and we get 1 over 8 times x minus 2. Negative 4, you move it to the other side, becomes positive 4, and negative 2 is positive 2. Y equals 1 8x plus 2. And I want to make a point that this point belongs to the original function, and it belongs to the tangent line, so it should work, and it does, of course. We're done with that. However, I want to go with the second method for practice to show you how we find the slope with that one. Sometimes one is easier than the other one. Therefore, m, or f prime of 16, is the limit as x approaches 16 of f of x minus f of 16 over x minus 16. So it's the second method we want to use. So therefore, we're going to replace the f of x with square root of x, and f of 16 with the y coordinate of 4. And you notice if we plug in 16, what happens? Square root of 16 is 4 minus 4 is 0. 16 over minus 16 is 0. You get 0 over 0. And as always, it is the 0 in the denominator, which is a problem. Because square root is involved, we multiply by the conjugate of the numerator and divide by it. The conjugate is the same thing with a plus sign in between. And so, again, the denominator, nothing happens. You keep it as a product because you're hoping to get rid of x minus 16. The numerator, the product of these two is square root of x, quantity squared, minus 4 squared, which is x minus 16. This goes away, this goes away. The numerator becomes 1. And you put this here, you get the same slope 1/8 as you did before. Again, you don't have to do both ways, but we want to make sure we can easily practice to get comfortable with this. The height in inches of a sunflower X weeks after being planted can be approximated by this function, f of x equals 6x minus 1/4 x squared. How tall is it in 8 weeks? First and foremost, when it comes to units, any application problem, when units are given, you want to give it back with proper units. So in this case, simply elementary algebra, you want f of 8, which means 6 times 8 minus 1/4, 8 squared. This is 48. This is 64 minus 1/4 of 64, which is 16, and you get 32 inches. Same units here, okay? We continue with elementary algebra. We want to find the average rate of growth from the end of week 6 to the end of week 12. Understand, this is average. This is rise over run. Delta y over delta x. This is f of x up 2 minus f of x up 1 over x up 2 minus x up 1. And therefore, we are looking for f of 12 minus f of 6 over 12 minus 6. So that's Pretty straightforward, everybody. So it's all a matter of plugging in and coming up with the answer. So f of 12, 6 times 12 minus 1 4 12 squared, minus f of 6, 6 times 6 minus 1 4 6 squared. So we write this. So 6 times 12 is 72. 12 squared, 144. 1 4th of that is 36. So we have 72 minus 36. Minus. This is 36. This is 36. 1 4th of it is 9. So 36 minus 1. Notice we have 72 minus 36 minus. If you distribute this, you get minus plus, and this 3 add up to 0. So you get 9 over 6, or 3 halves of an inch per inch. So this page was elementary algebra. There is really not much to it, everybody. Let's look at calculus. Find the instantaneous rate of growth 10 weeks after planting. And again, reminding you, this is the function. And so what we need to do, we got to use one of those formulas. Okay. For example, the first one, and find f prime of a. So f prime of 10 is limit of f of x minus f of 10 over x minus 10 as x approaches. So the limit as x approaches 10, the denominator is x minus 10. What is f of x? You put this function minus what is f of 10? You plug in 6 times 10 minus 1 4th, 10 squared. And basically, we have to simplify the numerator. That's why sometimes people simplify this and then apply the limit at the end. That's fine as long as you remember to apply the limit and keep the limit sign before you replace the x with 10 at the end. In any event, so what happens here? First of all, this is 60. This is 100. Let me just have 60 here. This is 100. And 1 4th of it is 25. So 60 minus 25 is 35. And as you notice, because of this negative 1 4th, this becomes a complex fraction. To simplify complex fraction, we're going to multiply the bottom and the top by LCD, which is 4. So we're going to multiply everything by 4. So 4 at top, 4 at the bottom. First, I want to discuss the denominator. You just keep it as a product of 4 and x minus 10, because as x approaches 10, x minus 10 approaches 0, and that's a problem. Now, if we're going to distribute here, we get 4 times 6x, 24x. Distribute here, and this goes away. We get minus x squared minus 35 times 4 is minus 140. Because we are interested in factoring, we're going to put this in descending order, which means minus x squared comes first. I'm talking about the numerator and the numerator only for now. To factor this, we like the coefficient to be positive, so we're going to take out the negative and we get x squared minus 24x plus 1, which means now this negative sign, you can leave it outside or inside the limit sign, makes no difference. If you want to factor this, I'm going to give you a couple of items here. Number one, you want two numbers. The product is positive 140. The sum is negative 20. Number two, Remember, x is approaching 10 and x minus 10 creates a problem giving you 0 in the denominator. So you're hoping the top has a factor of x minus 10 to get rid of, and that's the way you can easily factor it. You want two numbers. The product is 140. The sum is negative 24. The numbers are negative 10 and negative 14. The product is positive 140 and their sum is negative 24. X minus 10 drops. And notice the negative sign is just out or in, makes no difference. We keep the negative sign, we don't lose it. And now if you plug in, the numerator becomes 10 minus 14, which is negative 4. Negative 4 over 4 is negative 1, with the negative in front becomes positive 1. Therefore, f prime of 10 is positive 1 inch per week. And so what? What does it mean? Explain the meaning of your answer to part C. What does that mean? On week 10 or after week 10, the sunflower is growing at a rate of 1 inch per week. Now, but I want you to know that positive means increasing, negative means decreasing. Okay, so in this case, it's increasing because it's positive. So, a quick recap. The previous page was all about elementary algebra. This page was differentiation by definition, which is calculus. Now, this question sort of is taking us to the next section. Suppose that a ball is dropped from the upper observation deck of CN Tower, which is 450 meters above the ground, and the formula S equals f of t or 4.9 t squared. You may remember that S is half of gt squared, and the g force is 9.8 meter per square second, is half of that. What is the velocity of the ball after 5 seconds? What is the velocity when it hits the ground? Or how fast is the ball traveling when it hits the ground? Notice we want to calculate the velocity at one point, which means a differentiation. And for this one at a equals 5, for this one at a equals something else that we need to calculate. So notice I have to do it 2 times. I have to do the differentiation 2 times, but in the next section, we discuss the differentiation function. So instead of f prime of a, we look at f prime of x in general. So in this case, we can keep the a and not change it to a specific number. So having said that, we're going to go with v of a equals limit of f of a plus h minus f of a over h as h approaches 0. For this one, we have to change the a to 5. For this one, we have to change the a to whatever it gives us. So we're going to keep it as a. Imagine it's the function, and you see how easy this becomes because you don't have to do this 2 times. What is f of a plus h? You go to this formula, you get 4.9 times a plus h quantity squared minus what is f of a? F minus 4.9 a squared. So we are keeping it at a. In the next section, we would go, because this is v of t in essence. Doesn't matter. All right. A plus h squared is a squared plus 2ah plus h squared. So I can take the 4.9 out, and this remains in the following manner. So this is a squared plus 2ah plus h squared. Because 4.9 is in common, you take it out from here and you get minus a squared. So these two cancel each other. So now we have 4.9 times 2ah plus h squared over h, and there's a common factor of h in the numerator we can take out. And so now we have the limit of 4.9 times 2a plus h as h approaches 0. Now, if you apply the h equals 0, you get 4.9 times 2a, which is 9.8. Notice, we say whatever a is, the velocity of a is 9.8a. So T equals any number A, V of A is 9.88. So for this one, what is A? 5. So 9.8 times 5, 49 meters per second. What about this one? First, we have to find the T. It's going to hit the ground. It's going to cover 450 meters. So F of T, which is 4.9 T squared equals 450. We're going to solve for T, which means we're going to divide by 4.9. And then we're going to take a square root of that. And normally you want to go with a lot of decimals, depending on type of question. This is an approximation, by the way. And I'm going to just go with 9.6. Okay, I did the round. And I'm going to go back to this one. V of A is 9.88, and A is in part B, 9.6. And their product, 94.08 meters per second. So this is in essence taking us to the next section. Instead of finding V of A, in essence, V of T, which is S prime of T, if you will. That's what we do. And the advantage of that is that if you want to find V at different A's, in part A, the A is different than in part B, then you don't have to redo the process. All you have to do just plug in, and it makes it nice and easy in that manner.